Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over naming monatomic ions, anions and cations, positive ions and negative ions. So let's get into this. So I'm first going to start off with naming the monatomic cations, that is the positive ions. So the way I remember cations are positive is because the T in cat looks like a positive sign, so I remember cations are positive ions, plus ions. Okay, so how do we name the positive ions? The positive monatomic ions, that is, ions that are made up of only one atom with a charge. So I need to convert this, or I need to divide this into two different categories, those that are transition elements and those that are not transition elements, because we're going to name those slightly differently. So what about the non-transition elements? Those would be the elements in groups 1A through 8A. So let me specify that. So the non-transition elements, these would be the groups 1A, oops, 1A, not A1, unless you're talking about the Tabasco sauce, or not Tabasco sauce, the barbecue sauce. I can't get my sauces right. So 1A through 8A. Okay, so this would be your main group, elements. So not transition elements. So in this case, the way you name the ion is it's going to be just the name of the element plus the word ion. It is that simple. So here I have a few examples. So Na is sodium. So the element name is sodium. Na plus is the sodium ion. No changes to the name, just the name of the element plus the word ion. Ca is calcium. That's the neutral atom. The ion with the 2 plus charge is going to be called the calcium ion. Next, we have aluminum. Al is aluminum. That's the name of the neutral element. The ion is going to be called aluminum ion. Al with the 3 plus charge is the aluminum ion. So for non-transition elements, and we're talking about cations only, the positive ions that are metals, usually metals, it's just going to be the name of the element followed by the word ion. So sodium ion, calcium ion, aluminum ion, and so on. Now, what about transition elements? That would be the B groups, or that group of elements in the middle part of your periodic table. Well, it's same idea, but we're going to add a little thing, a little extra. So again, for the transition element, it's going to be the name of the element for the ion, but we're going to add a Roman numeral. The Roman numeral is for the charge on the ion. The reason for the Roman numeral is because in a large majority of the transition elements, they're going to have multiple charges. So we need to identify the ions from each other. We need to distinguish between, say, an iron atom with a 2 plus charge or an iron atom with a 3 plus charge. We can't call them both iron ions because they're different charges, they're different ions. So the best way and easiest way to distinguish between them is to give a Roman numeral for the charge. So the iron 2 ion, or I should say the Fe2 plus ion, would be called iron 2 because the charge is a plus 2 charge. If you have a 3 plus charge on your iron ion, then it would be iron 3, 3 for the 3 plus charge on your iron atom. And so that's the difference between your main group elements and your transition elements. We're going to add a Roman numeral for the charge. And again, that's because transition elements tend to have more than one charge. Your main group elements, for the most part, only have one charge. So there's no need for a Roman numeral because the charge is always going to be that charge. So for example, sodium has a +1 charge because it's in group 1. Group 1 elements, or the group 1A elements, always have a 1 plus charge. That's all they ever have. So you don't need a Roman numeral to identify the charge because you already know the charge based on the group number. So group number 1A has a +1 charge. So for calcium, for the calcium atom that's in group 2A, group 2A elements always have a 2+ charge. So any element in there will have a 2+ charge and only a 2+ charge, and so on. So aluminum is in group 3, it has a 3+ charge. And then on the non-metals, the same thing. So we can figure out what charge it is. There's only ever one charge, and that's just the charge that it will have. So based on the group number as well. But for the transition elements, you can have multiple charges, and so you need a Roman numeral to identify what the charge is on your ion, so you can identify what kind of ion you have. So we need to name them differently based on their charges. So for example, if I have copper, Cu is copper, that's the name of the element. The Cu plus ion is going to be copper 1 because it has a 1+ charge here. So we call it the copper 1 ion. The Cu2 plus ion has a charge of a 2+, and so we call it the copper 2 ion. So we need to identify what the ion here that we're talking about, so we name them differently. They got to have different names because they're different ions with different charges. Mn is manganese. Mn2 plus is going to be the manganese 2 ion. And so that's how you name your monatomic cations. Now, before I go on to the anions, there are some exceptions to this rule. Now, this rule is a general rule of thumb. If it's not a transition element, then it's not going to have a Roman numeral. If it is a transition element, it will have a Roman numeral. That is a rule of thumb. It's not an absolute rule because there are exceptions, and you need to know those exceptions. So what are the notable exceptions? These 5 here are the notable exceptions. So silver, cadmium, and zinc, they are transition elements, but they will not have a Roman numeral because by and large they only have one charge. So since they only have one charge, you just need to remember that charge on that ion. So you don't name it with a Roman numeral. So for example, we have silver. So this Ag plus ion, we're not going to call that silver 1 ion. We're going to call that the silver ion. The reason for that is because the +1 charge on the silver ion is by far the most common charge on your silver. Now, silver can have a 2+ charge, but it's so rare that we don't really distinguish between silver 1 and silver 2. We do distinguish between them, but we don't give a Roman numeral to the silver because that is by and large the most common charge you're going to have. And then if there is a silver 2 ion, then we call that silver 2 with the charge. But we don't use a Roman numeral for silver plus. Same thing goes for cadmium and zinc. Cadmium only ever has a 2+ charge. Zinc only ever has a 2+ charge. So there's no need for a Roman numeral for those transition elements. For these two, lead and tin are technically main group elements. They're in the group A's, right? So tin is in group 4A, and lead, they're both in group 4A. So they are main group elements, but in this case, they do require a Roman numeral because they can have multiple charges. So lead can have multiple charges. It could be a 2+ charge or a 4+ charge or something like that. The same thing with tin. So for those two, you need to remember to put a Roman numeral. So for example, lead, Pb is lead, but Pb4+ is going to be lead 4 ion, not lead ion, but lead 4. You need the Roman numeral for those. And so that's it for the monatomic cations. Let's move into the naming of the monatomic anions. Okay, let's talk about the anions now. So when we're naming the monatomic anions, those are the negative ions, then basically what you're going to do is you're going to take the name of the element that the ion is, and then you're going to drop the ending, keep the root, drop the ending, add IDE to the end of it, and then plus the word ion. So let's go over a few examples here. So here I have carbon with a 4 minus charge. If carbon had a 4 plus charge on it, then we would just call it the carbon ion. As we saw before for the cations, it would just be the name of the element carbon plus the word ion. But if carbon has a 4 negative charge on it, then what we would do is drop the ending. So here we would drop the ending, keep the root, add IDE to the root, and then add the word ion. So carbon becomes the carbide ion, nitrogen is an N, right? But when it's a charge of a 3 minus, then we take the word nitrogen, we take its name, we drop the ending and keep the root. In this case, the root is NITR, niter, and we drop ogen, OGEN, and we replace that with ide and add ion. So nitrogen becomes the nitride ion. Same with phosphorus. So phosphorus, we're going to drop the ending, ORUS, the orus ending, and we're going to keep the root phosp. And we're going to add IDE and the word ion. So phosphorus becomes phosphide ion. Same for oxygen. So oxygen with a 2 minus charge. We're going to take the name oxygen, drop the ending, very similar to nitrogen, OGE ending. Here we're going to drop the YGE ending. And then we're going to add IDE. And so we get the word, we get the name oxide ion. Oxygen becomes the oxide ion. Sulfur, same group as oxygen, so it also has a 2 minus charge. And so sulfur basically will become the ion. How do we name the ion? We drop the ending. In this case, the UR ending is dropped. SULF, the sulf is the root. We're going to add IDE to the end, and then add the word ion. So sulfur becomes the sulfide ion. Same for selenium. Selenium forms a 2 plus charge, or I'm sorry, 2 minus charge, just like oxygen and sulfur, because selenium is in the same group as these two. And so selenium, we're going to drop the ending IUM, the eum part, and SELEN, selen is the root. We're going to add IDE to the end of that, and then add the word ion. So selenium becomes the selenide ion. And then fluorine with a charge becomes the fluoride ion. We drop the INE ending, so this ending gets dropped. We replace it with the IDE ending and add ion. So fluorine becomes the fluoride ion. And then continuing with the other halogens in group 7, the same thing occurs. So chlorine becomes the chloride ion. So Cl minus, we're going to take chlorine, drop the INE ending, add IDE, and then the word ion. So chlorine becomes the chloride ion, fluorine becomes the fluoride ion, bromine becomes the bromide ion, iodine or iodine becomes the iodide ion, and so on. So that's how you name your negative monoatomic ions. You're going to take the name of the element, drop the ending, keep the root, add IDE to the end with the root, and then add the word ion. So carbide ion, carbon, carbide ion, and so on. So that's how you name your monoatomic anions and cations. I hope this video is helpful. If it was, then please by all means like the video, share the video, hit that like button over there somewhere, and also make sure that you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. I would love to hear from you. Let me know what you think. Ask me questions. If you have a particular problem you want me to go over, I would love to do that for you. If you have a topic you want me to cover, I would love to do that for you as well. Thanks for joining me and have a great day.